solving inequalities. An inequality is an algebraic statement in which two quantities are unequal. Well, we're looking at four symbols. This symbol represents greater than, and it's, of course, written like this, very simple symbol to remember. And we have less than, written this way. Now, notice these two are kind of the same, however, we have this line segment below it, meaning this is greater than or equal to. That's very important. And then we have less than or equal to. Two very important concepts related to our first initial. So these four inequality symbols we're going to be very familiar with. Example number 1. We have 2x plus 3 is greater than 9, a greater than symbol. So what we're looking for, we're trying to find the solution for x to make the statement true. What number, when we put that number in here, substitute that number for x, will make this true? Well, that's what we're going to find out. Very simple. 2x plus 3 is greater than 9. The key is, the process, we want to isolate our variable. And in this case, our variable is x. The coefficient of our x is 2. And in addition to that, we have our 3. So we can eliminate 3 from this side of our inequality. Let us subtract 3 from this side. And of course, what we do to one side of the equation, we have to do to the other side. So let's subtract 3 from that side. So now we have positive 3, negative 3, they cancel. So we're left with 2x is greater than, we have a 9, and from that 9, we're subtracting 3, we have 6. Now we have 2x is greater than 6. Well, we want our variable to be by itself. We want to isolate our variable, which is x. Well, what this statement says is 2 times x is greater than 6. To eliminate this 2, we must divide by the coefficient of the variable. Our variable is x, the coefficient of x is 2. So we're going to divide both sides of our inequality by 2. Divide this side by 2 and divide this side by 2. 2 divided by 2 is 1, or x. And that's the key. We want our x to be by itself. 1x is greater than 6 divided by 2 is 3. So that is our solution. X is greater than 3. Now let's draw a picture of what this means, because if we can draw a picture of it, it makes a lot more sense to us. So I'm going to make a quick number line here. I'm going to say this is our 0 point. We have our negative 1, negative 2, positive 1, positive 2, positive 3, positive 4. So looking at our solution, x is greater than 3. So here's our 3 point. Now what I'm going to do is draw an open circle, meaning it does not include 3. Our solution to this is any number greater than 3 will fit. Now let's think about this. We're saying that any number greater than 3 will fit. So this problem does not have just one answer, but it has an infinite number of solutions to it. 10 will work, 14 will work, 1,000,000 will work. Any number greater than 3, but not including 3, will work for this equation. Let's look at our second example, example 2. The same process. The key is to isolate our variable. We want our x, in this case, to be by itself on one side of the equation. So we have 4x minus 2 is, in this case, our symbol, less than 14. Well, we have 4x. Next to our 4x, we have a negative 2. Let's get rid of that negative 2, so we begin to isolate our variable. We have a negative 2, so to that negative 2, let's add the opposite to eliminate it. So to that negative 2, we're going to add 2. And what we do to one side of our inequality, we have to do to the other side. Let's add 2 to this side. So we have a negative 2 and a positive 2. What happens to them? They cancel out. They're gone. So now we have 4x is less than, we have 14 plus 2, 16. Okay, so we're saying some number times 4 has to be less than 16 for this to be true. Okay, again, our variable is x, and the coefficient of our variable is 4. Well, we want x to be by itself, so we're going to eliminate this 4 by dividing by the coefficient. So we're going to divide both sides of our inequality by 4. And why? Because we want our x to be by itself. That's the key. We want to isolate the variable. So let's divide this side by 4 and this side by 4. 4 divided by 4 is 1, and we have our x by itself. That's what we're looking for. And that is less than 16 divided by 4 is 4. And here's our solution. Any number x less than 4. So again, we can draw a picture of this to see if it makes sense. So let's start with our 0, and we have 1, 2, 3, 4, put another one here, 5. Then I have a -1, -2, -3. So we're saying the solution x is less than 4. So let's identify the 4, and again it's going to be an open circle indicating it does not include 4, x less than 4. So it's going to include every number to the left of 4 is our solution. Let's just pick a number out, 0. And let's plug it into our equation. 0 times 4 would be 0, and our solution would be -2. So is -2 less than 14? Yes, it's true. So you can pick out any one of these integers and plug it in for x, and the solution will always be true. So we've drawn a picture of the solution. And sometimes when you're able to draw a picture of the solution, it makes a whole lot more sense in terms of what we're talking about. Example 3. We have, again, our variable y divided by 3 plus 6 is less than or equal to 18, our inequality sign. So again, what's the key here? What's the focus? What is it that we want to accomplish? And it is to isolate the variable. And that's the one thing we should always keep in mind, because once we've isolated our variable, we have found the solution to this inequality. So the way the problem reads is some number divided by 3 plus 6 is less than or equal to 18. Now it may seem difficult, but remember our process. Now we have our y divided by 3 plus 6. Well, let's start to isolate it. Subtract 6 from this side. Now, what we do to one side, we have to do to the other side. Let us subtract 6 from this side. So we have a positive 6 and a negative 6, and what happens to that? They cancel out. They're gone. So now we're left with, we have y divided by 3 is less than or equal to, and we have 18 minus 6 is 12. Okay? And again, let's ask ourselves, what are we asked to do here? Some number divided by 3 is less than or equal to 12. Well, we know that to isolate our variable, in this case we have a denominator of 3. Now, this y over 3 is the same as y times 1/3. They're equivalent. Now, to eliminate this 3, we're going to multiply both sides by the inverse of the coefficient of our variable. Our coefficient, well, our variable we know is y. The coefficient, the number next to our variable, is 1/3. So let's multiply the inverse of 1/3. And the reason we do that is because 1/3 times its inverse, 3 over 1, is equal to 1 whole unit. One way to show that, 1 times 3 is 3. 3 times 1 is 3. 3 divided by 3 is equal to 1. And that's what we're getting at here. We'll have a 1 next to our variable. So let's multiply this side by 3 over 1, this side by 3 over 1. Our 3's cancel, and we're left with a y. Y is less than or equal to 12 times 3 over 1, which is the same as 12 over 1 times, of course, 3 over 1, which is the same as 12 times 3. And we know that 12 times 3 is equal to 36. So 12 times 3 over 1 is equal to 36. And here's our solution. Y, any number y, less than or equal to 36 would be the solution to this inequality. Now let's demonstrate this on a number line. We're going to create an abridged number line. We have a number line, this is 0, and then I have this to indicate part of it has been taken out. So we have 1, 2, -1, -2. Now let's start at 34, 35, 36, 37. So our solution in this case is y is less than or equal to 36. So including 36. This time I'm going to draw in a closed circle and represent this. This is our solution. So our solution starts from 36 to negative infinity, or forever and ever, any integer less than 36. Example number 4, there's a principle that we're working with this problem. It's called the multiplication principle of inequality. And what we're working with here is whenever we divide or multiply both sides of our inequality with a negative term, then we change the direction of the inequality. So our variable in this case is x. The coefficient of our variable is -3. So again, we want to isolate the x. Let's get rid of our coefficient, -3, and to do that, we're going to divide both sides of the equation by the coefficient. In this case, -3, -3, -3. And that's where our principle comes into play. We're dividing by a negative term. -3 divided by -3 is x. We always want our x to be positive. This changes. X is less than 15 divided by -3 is -5. Here is our solution. X is less than -5.
I like to stress an important rule. When multiplying or dividing by a negative, it changes the direction of the inequality. For instance, this is less than. To solve this equation, we divide each side by -5. -5, that cancels this side out. So -5 divided into 35 becomes 7 times 5, so it's -7. And this less than becomes greater than. And so when you multiply or divide, don't forget to change the direction of the inequality.
Please pause the video now and complete the problems in your workbook. When finished, press play, and we'll continue with the next lesson.